Right, hi everyone. I think my presentation's been set up relatively well by Martin, and Irving also gave a good overview as to some of the benefits of our technology. So I'm here today to talk to you about Soluboard, which is an alternative end-of-life solution for PCBs, both existing and the future. So in 2017, I invented the first version of Soluboard at university. I was given a brief by my design tutor in London to choose a waste stream to try and optimize. So I selected e-waste, which was and still is the fastest growing waste stream in the world. So this was the first prototype that I produced using conductive silver ink based on a through-hole component version of a microcontroller called an Arduino Uno. So off the back of that, I was able to file a patent, start the company, and we are now at the point where we have the mission to tackle e-waste using naturally derived materials to produce PCBs with reduced carbon emissions and an alternative end-of-life solution. So I'm sure everyone in the room is aware of the problem, and it's been covered by a number of presentations today already, but I think expanding on the rigid PCBs, it should be known that mainstream PCB substrates aren't designed with recyclability in mind. And Martin mentioned it earlier, only about 40 to 60% of a panel of rigid PCB laminates actually becomes a PCB. And that picture on the right-hand side there is actually from one of our PCB fabrication subcontractors. That's their waste bin from just one day. So there's a significant amount of waste. And it should also be noted that that isn't considered in the e-waste numbers. So about 62 million tons of e-waste, not including this scrap, was produced in 2022, with about 82 million tons expected to be produced by 2030. And PCBs make up just over 40% of this e-waste by weight, which makes them the highest contributing polluter to this e-waste stream. The fact that these substrates aren't optimized for recyclability means that about 9 to 10 billion euros of precious metals are landfilled every year due to the fact that they can't be efficiently or economically recovered. And there's also about 6 million tons of CO2 emissions produced from existing PCB disposal for the PCBs that are recovered and recycled. So this is our solution. This is Soluboard, which is produced using fully biodegradable and non-toxic natural fibres. The clue's in the name. It's also fully recyclable in our novel hot water-based recycling process, which allows us to avoid the incineration at end of life and improve the precious metal recovery rates. When you look at FR4, which is by far the most common incumbent in the rigid PCB laminate industry, we have a 67% lower carbon footprint. We also have close to a 60% lower carbon footprint compared to SEM1, which is used in lower end, lower technology PCBs. So this is where we differ at the moment. Although my journey started in printed electronics, we now predominantly supply our material as a copper-clad laminate for standard PCB etching fabrication. This has been driven largely by the customer demands coming our way. But we are still compatible with conductive inks and adhesives for the additive applications. And we happy to say that we have mechanically and electrically comparable properties to these rigid PCB incumbents. But there are a huge variety of options out there for the OEM. When specifying a product, FR4 tends to be the most common choice, but there are flexible circuits. There are the likes of FR4, which I've mentioned, and SEM3, which are robust and versatile. You have low-cost options, such as FR2 and SEM1. And if you're looking at improving signal integrity, you look at foam, PTFE, ceramic. And if you're looking for heat dissipation properties, you might look at IMS. But this is our position in the market. If you're looking for a substrate for a single-use application in products with shorter lifespans, or in products where they're recovered via regulatory take-back schemes and you end up with an